Cameras and image processing have come a long way, and thanks to a NASA technology, it happened a lot more quickly just over the past 20 years. During the early 1990s at the Jet Propulsion Laboratory, Dr. Eric Fossum led a team investigating new imaging technology that could reduce the size of cameras flying on interplanetary spacecraft.
They really wanted to have a technology that wouldn't cost a tremendous amount of money to develop and have a very small camera that didn't consume much power, and also something that they could actually customize for the particular application.
In their research, the team was using complementary metal oxide semiconductor material, also known as CMOS, which is for microprocessor chips.
Eric saw, the ability to put an amplifier in the pixel with CMOS active pixel type of technology, and it worked through many of the issues that were sort of holding back MOS type devices, and showed that actually you can develop an imager with very good performance relative to some of the other competing CCD technology and other type of MOS technologies.
And Fossum invented what is now universally known as the Active Pixel Sensor, or APS. While Fossum's team continued to work on the APS, they started a firm called Photobit and licensed the technology through an agreement between NASA's Jet Propulsion Laboratory and the California Institute of Technology. Photobit improved APS for a variety of applications, from medical imaging to machine vision applications, to high-speed applications, to web cameras and digital still cameras. Along the way, the firm also advanced the technology through small business innovation research contracts from the Johnson Space Center as well as the Department of Defense. But a particular application really set things in motion. A number of Asian cell phone manufacturers began adopting the technology.
In Japan, where people were buying phones every year and people really were kind of excited about new technologies, was the first place where we started seeing cell phone cameras pop up with CMOS devices.
Meanwhile, in 2001, Micron acquired Photobit.
They had the manufacturing capacity and the silicon fabrication technology to really take the next step from being kind of a startup mode to giving us real big scale to address the markets that we're entering into.
More recently, Micron spun off the imaging sector known as Aptina so it could focus on the rapidly growing business and technology. APS continues to progress, keeping pace with advances in the semiconductor industry, which translates into new applications for the future, such as surveillance. Today, no one knows just how far the active pixel sensor can go.
That's the other beauty of the technology. You can integrate the analog readout electronics, the analog to digital converter, and all the image processing on there, really to output true camera quality video or still images off that one chip.